Welcome to this section. By now you know what are VLANs or virtual LANs and what are the collision domains and broadcast domain. With the exercise I told you in the previous section, you might have also figured out what are the differences and how to spot where are the collision domains and what are the broadcast domains. Now the next concept is very crucial when it comes to networking, and that is the concept of subnets. Please stay focused over the course of this section, and in this part we are going to discuss the concept of subnets, subnetting, subnet mask and everything. So let's dive in. The very first topic is the subnet. A subnetwork or a subnet is a smaller portion of a large network. In simple terms, when a larger network is broken and divided into smaller individual networks, those smaller networks are known as the subnetworks or the subnets. So like if you have a parent network A that contains 100 nodes, if you divide that parent network into 5 networks that contains 20 nodes each, then those smaller partitions of network will be called as the subnets or the subnetworks. Such partitioning is done so as to reduce the traffic on the main network. When smaller individual networks are formed, every network will handle its own traffic and thus act as individual. This is the biggest advantage of forming such smaller networks or subnetworks. But this division into subnets comes with one problem, and that is once these subnets are formed, once you have divided the parent network into 5 different networks that contains 20 nodes each, these smaller networks or subnetworks, they act as completely individual and independent networks. This is good when the subnets want to work alone and separately, but the problem arises when these subnets have to talk to each other. This means when it comes to collaborative communication, when the subnets wants to work as a team, these subnets cannot work together because of the segmentation by which they were formed. In order to make them talk or message each other, we need to provide them with a way to communicate across each other, and that is the way of routing. The figure shows a parent network A, that is the 100.0.0.0. This is the parent network A. Let's say this network consists of 100 nodes. You have segregated the network A that consists of 100 nodes into 4 subnetworks, that is subnet A with this address, subnet B, subnet C and subnet D. So we have 4 subnets, subnet A, B, C and D originating from the parent network A. So the subnet A has an address of 100.56.23.0. The subnet B has an address of 100.10.12.0. The subnet C has an address of 100.100.1.0. The subnet D at the last have the address of 100.23.17.0. There is one pattern if you have noted that these subnets have the first part as the parent network address. So if you can see, the parent network has the first part of the IP as the 100, and that is reflected in all of the subnet addresses. And this is correct because this acts as a proof that the network A has given birth or the subnets has been derived from the parent network A, that was the 100. So since this is the parent and this are the children, they will have the parent network 100 inside them. Everything that is given after the 100 is up to them, but 100 is mandatory because that has been derived by the parent network. But this division or this segmentation is not as simple as drawing a bigger circle for a parent network and drawing smaller circles for the subnetworks. There is a detailed, interesting logic behind the division, and that is with the use of subnet mask.